Alright, this is our first part in a series of videos about the EWPI Buildup. This is simulated avionics for the F-16. Looks like this right here. Nice little unit. And what we're going to be using is eventually we're using two Osram displays, one for the top, one for the bottom. And we're going to use the atmega 324P chip as our microcontroller to drive these two Osram displays, and then we're going to use USB to R232 TTL serial converter. Basically, it's going to take the data from Falcon 4. If you saw my other video I did on extracting the data from Falcon 4 with a C# program, and basically we're going to send that data over one of these little USB converters to the microcontroller, the 324 microcontroller, and then the microcontroller is going to display the data, or chaff, flare count, and all the other data, display it on the Osram displays. Now, as far as these little converters, you can get them on eBay or Amazon. They're pretty cheap. These ones are from China. I got one. Just make sure that if you can, the headers on these, some of them are a little shorter than other ones. If you can get the ones that are long enough, they'll plug straight into your breadboard, which is nice. And I hadn't even seen these ones that come in like 90 degrees there, 90-degree angle. I don't know if those are better or not. But if you get one to plug right into your board, then that looks nice and save you some wiring. Mine uses a Silicon Labs chip, and these basically take a lot of the work out for you. You don't have to write drivers. USB driver. Basically what it does is set up a virtual COM port on your computer, so you can send serial data from your program on your computer, which in this case is going to be our C# program that's extracting data from the Falcon 4 and then sending it over the USB cable into this converter, and then from this converter it's just into the serial port of the or basically the serial pin of the microcontroller, and then to the display. This is going to be our microcontroller here. I assume you've watched Patrick's videos and you have all the beginning basics of flash programming the chip, and some familiarity with it through his lessons. Or if you already know what you're doing as far as this goes, then you don't need those lessons. But I'm assuming this is all from a complete beginner's standpoint. I'm a beginner myself, so you will see all my errors here, and we'll try to go through this step by step in a simple form, simple as I can make it. Now I'm going to be using this Osram display for this set of videos, the IPD 2545, which is a very pricey one. I just had it lying around, and basically, even though the final display we'll be using is a different Osram display, it's very similar to this. And if you can program this, you can program the one we're going to use in the end. I have it wired up, and I don't want to pull everything apart because I have it working, and I'm going to use it as a reference for when I screw up. I can go back to that and see if I've made a wiring mistake, whatever. I can reference it because I know it's working. It's a working unit, and this one hasn't even been wired yet. So we'll just do this step by step and make our mistakes here, and I can reference back to it. But like I said, you can just use once you know how to program this display. The other ones are almost identical, very similar. They're set up. This one we'll be using as 20 pins, and we won't be using all the pins. We'll be using the bus pins here, the data pins. You have D0 to D7, with D0 being the least significant bit, and that's from pins 19 through 12. And then you have you have your write bit when you want to write the data from the microcontroller into the display. And then you have your ground and your VCC, which is your voltage source. We'll be using the 5 volts that we're using to power the. I have a 5 volt power supply wired into the breadboard that powers the microcontroller and the display. And then you have your ground, and then you have your A0 through A2. These 3 pins tell which one of the digits here you want to light up and send data to. So each one of these 4 digits, and in the other display it's I guess it's 8. You're able to address through your ones and zeros through these 3 digits here. You can address, say, okay, I want to light this one here to the far right, or I want to light this digit to the far left. And whatever combination you set up in your programming, there's a little chip inside this display. It's like an intelligent display where basically like a little microcontroller inside it that you're talking to, and it's smart enough to know where you're sending the ASCII information, or the digit, number, letter, whatever it is you're sending. And then you have your chips, your chip enable 1 and 0. Obviously these will enable your chip, turn it on and off. You have a reset pin, basically clears the memory, starts everything from scratch. And then you have your and it's active low, which basically means that to make it work you drive it low, you send it a 0. We have your clock select and your clock input output. These 2 pins are when you're cascading, running multiple displays, which we will be doing because we have 2 of them to drive. And 1 pin will synchronize, say when you want to flash the 2 displays, it'll synchronize them so they flash at the same rate. And then one pin or one display will be set up as the master, and then the other displays are set up as slaves. So they take their timing and their data from your master chip, your master display, and are controlled from it. You have your read pin. We won't be doing any reading of the chip. We're trying to keep this as simple as possible. It uses the least number of pins. If we don't need to send it any data, then we'll either ground it or hook it up to power, and not even use a pin on the microcontroller. Basically the wiring diagram here, set it up to be simple once again as possible. We're going to use the port C port on the microcontroller as our data bus, and remember the our data bits on the display are from 0 to 7, and so we're going to match them on the microcontroller with our port C. I haven't tried port C. I had problems with it apparently before. Apparently it's JTAG can interfere. You can get some wacky behavior on it if you don't disable the JTAG on it, which I covered in my other video on the doing the fuses, programming the fuse bits. So we're going to try port C. We're going to disable, or we're going to run as disabled JTAG on the fuse bits, and then we'll see how it works. And if we have problems, we can switch it to another port, try that out, try to get something, so keep playing with it until it works. I'm going to hook the read-write pin up to port A, pin 7. The VCC for the display, obviously, it's just we're gonna put it to 5 volts. I'm going to run the read pin to, I'm not sure if this is good or not, but we're going to try running it to 5 volts because we're not going to use it in its active low, so it'll always stay high. Excuse me. I'm not sure if these are, you can leave these floating or not. In other words, not connected, just leave them unconnected. But we'll try the ones that we're not going to use, like the clock select, the clock input output. And we're not even going to hook those up. They're not even going to be connected. VCC obviously is going to be connected, and ground. It's going to be connected to ground. And over here you can see our A0 through A2 pins. Remember, those are the 3 used to drive each single digit on the display. You have them hooked up to their port A pins, and reset set to port A pin as well. So for the beginning part, like I said, we're just gonna hook up the microcontroller to the display and get it running, get the display running, and make sure it's acting properly. We'll send it some data directly from the microcontroller into the display. Once we're sure we have that functioning properly, then we'll hook up the serial part of it from the USB converter. Alright, we'll see you in part 2.